So next up we discuss packages in Python. We have discussed them a bit, right? Now we are going to just focus on a few packages and quickly get introduced to them. What are the packages that we will be discussing? We'll be discussing the numpy package. We'll be discussing the matplotlib package, right? We'll be discussing the Seaborn package, right? And we'll be discussing the scikit-learn package or sklearn package, right? So what are these packages? Again, like we discussed earlier in the when we were in the last class, that these packages are a collection of pre-written code or software that we can use in our codes, and it makes the programming much easier because many times you need some functions. Not just you are going to need those functions, a lot of people are going to need those functions. So if you have a function and you wrote that function and then you shared it with other people, so then other people will not really need to reinvent the wheel, so they can just use those predefined functions. Now how do we import these packages or these libraries? We use the import keyword. We say import, and we can write the name of the package that you want to import. Okay. Now let's say you want to import a package, but you then want to rename the package inside your code, right? Let's say if I just import numpy, right? Numpy, by the way, is a package that deals with arrays, right? And the functions that are defined on those arrays, right? It's a very useful package, and it's used a lot in the case of engineering applications. Okay. So then, if I want to access the member function of numpy, I can do something like numpy dot array, right? And I can do something, right? So this dot array is a member function of Python, right? Then I can have, let's say, numpy dot something, whatever, right? Okay. The thing is, numpy consists of how many characters? 5 characters. If I find that this is too long to write, yeah, one possibility, I say import numpy as np. Yeah, so this way the package numpy is going to be imported, but it's going to be renamed np. Whatever you want to put the name over there, you can do that, right? Np is generally a standard abbreviation that we use for numpy, right? So then, in place of doing numpy dot array, you can just do np dot array, right? Or in place of somewhere else, let's say you can do np dot something. For example, np dot all, or np dot amax or whatever, right? So you can access this member function this way. Okay. Why is it useful? One, it lets you use less number of characters, right? So it's a bit more compact. So that is one possibility. Another reason is, let's say 10 years from now, right, people created a new package which contained the functionalities of numpy, but they added a lot more functionalities, such that they called the new package numpy2, right? So in that case, if in the earlier example you had numpy dot array and you had numpy dot for example abs, right, whatever, right, or let's say amax. So if now you define a new package named numpy2 that contains the similar functionalities as numpy but adds a lot more, right? So you want to import or use those functionalities. So then if you just say import numpy2, then you would need to rename everywhere down below. So wherever numpy would appear, you need to make it numpy2. Yes?
Import numpy2 as numpy.
Exactly. So that's what we can do. Yeah, That's another possibility, right? You can also change the name, import numpy to as numpy, so that is going to fix the problem, right? Also, if you, so moral of the story, whenever you can rename a package is going to be helpful. That, let's say, if new versions of the package come out and if they have a different name, you can just use the same, if your import is as np, so you would not need to change the stuff down below. Clear? So we can write stuff as np, and yeah, everything is going to be solved. So that we discussed. Also, if I, when we say import numpy as np, right, or import numpy, what happens is, like, all the class definitions or the function definitions that are in there get imported in the memory of the computer. Yeah. Now, what if you do not need all of them? You just need just one or two of them, right? Let's say you want just the factorial function from the math package, right? One possibility is you say import math, and then you can access the factorial function as math.factorial, right? So that is one possibility. Another possibility is that you can say something like from math import factorial, and then you can just use the name factorial inside your code. For example, I need to find the factorial of 10. What is the factorial? You know what is a factorial, right? It's like 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? So if I run this, now it will function fine. Now the factorial of 10 is 3,628,800. Yeah, I did not know it by heart, I just saw it from there. Yeah. So moral of the story, that if you want just, let's say, one or two functions or one or two classes or class definitions from a certain package, so you can just say from package name and then import whatever you want to import. Clear? So what we discussed so far, packages, like we discussed earlier, are collection of pre-written software or code which we can use in our Python programs, so that we do not need to reinvent the wheel. And how do we import them? We can use the import keyword and the name of the package. If we want to rename the package, we can just say import the name of the package as the new name, right? And also, if we want to just import just one function out of the package, one class out of the package, we can just say from the package name import that guy. Okay, now let's dive a bit deeper in the numpy package. Let's talk about the numpy package. Now, numpy package is one of the most commonly used libraries in Python, right? And this is designed specifically for arrays, right? And why arrays are useful? Because a lot of data that we deal with can be modeled as arrays. Like, let's say one example is images, right? Now, images are what? It's a collection of pixels. Whenever you, let's say, buy a camera, right, you might they may advertise a 40 megapixels camera or 20 megapixels camera or 100 megapixels camera. By the way, if you are into photography, you might know that the number of megapixels doesn't necessarily translate to the quality of the image, right? Like 10 years or so ago, I had a Nikon D90, right? That was just 12 megapixels camera, right? But it would produce much better pictures than the state-of-the-art cell phone cameras at that time, right? So because camera quality is linked to other things as well. But what are these pixels? Pixels are picture elements, right? If you just zoom into a picture, you might notice that after some time you start to notice some blocks, right? Those are individual pixels. Yeah. So what are these individual pixels? They're just numbers, right? They're numbers. Let's say if it's a color image, so for each location of the image, you would have a red value, a green value, and the blue value, right? So when you load an image in the memory, right, you can load it as a matrix or an array, right? That will have 3 pages. One page for red channel, the other one for green, the third one for blue, right? And then you would have rows and columns, right? So rows of pixels and then columns of pixels, right? But when you load this, you're loading it as an array. So this is an example of very commonly used data that you can import as arrays. Other examples can be, let's say, you listen to music, right? Do you use MP3s anymore? Not really, right? You use probably Spotify or Apple Play or whatever, right? But at the back end, the data that is stored in some formats, right? For example, one format is MP3 format for music files. Now you can load those music files in your computers, and when you do that, if it's a stereo file, so you would see something that has, let's say, 2 columns and a large collection of numbers. What are those? Each column will be linked to, let's say, one column will be for the left ear, the other column is going to be for the right ear, and those numbers will be just the audio signal values. Yeah. So again, you can just load an MP3 file as a matrix as well. And similarly, there are tons of other examples which you can work with in the form of matrices. Let's say you have tabular data, right? So you can just use arrays to deal with those tabular data. Does that make sense? Clear? Clear? Clear. All right. Yeah, that we discussed. Now, how do we initialize numpy arrays? There are different ways to initialize numpy arrays. Just have a quick time check. Let's say I want to initialize a numpy array from a list, right? You understood lists in Python, right? So let's say I have I say import numpy as np, right? And let's say I say matrix A, and let me just write a 2-dimensional list, which is basically a list of lists, right? So let's say I have 1, 2, and 10. Let's say 13, and then I have 19, 34, 12, and 14, and then I can have, let's say, 45, 32, and then I can have 100, and then let's say 9, right? So if I just print this, this is just a list of lists. So in this list, I have 3 sublists. One of them is this one, the other one is this one, and the third one is this one, right? Now, if you want to, initialize a numpy array with this 2-dimensional list, I can do that. For example, I say array A equals np dot array, I say matrix A. So then if I print array A, it's going to just print the values of this guy. Yeah, and I can verify that this indeed is a numpy array. By what function? Type function, right? I can say type, and I do this. I can say this is an ND array, right? Similarly, if I had applied the type function on this matrix A, I would have gotten a list. Yeah, I can initialize, let's say, another matrix. Just say, let me call it matrix P, and then I can create a numpy array. I say array B equals np dot array and then matrix B, and then I can just print array A. I can just say print array B. Just run this. So you can say, you know, this top is array A, right, and this bottom is array B. So once I have converted them into arrays, I can perform the functions that are specific to arrays. For example, I can do array multiplication. Yeah. So for that, the function that we have in numpy is the dot function, np dot. So I say np dot. So will array A be will I be able to multiply array A to array B or array B to array A? Array A to array B, right? Why? Because the number of columns for the first matrix has to be equal to the number of rows for the second one. So I can say array A, and then I have array B, right? If I just do that, so you see this is the result of the matrix multiplication. Does that make sense? Yeah. Then I can do other things, like for example, I can add matrices, I can do you know, element wise multiplication, right? To do element wise multiplication, you have the dot multiply function, right, and so on and so forth. So there are like several functions that are specific to these arrays that you can perform on them. Next up, other functions. Let's say if you want to sort an array, right? So I want to say, let's say first I say print array before sorting. I say array A, and then I say array C equals np dot sort, and I say array A, and then I say print /n array after sorting, and maybe I can specify /n here, /n here. Okay, now here I did not specify along what axis I need to or I want the array to be sorted. So if I do not specify along what axis I need the array to be sorted, it will just sort it over the last axis, right? Like for example, it just sorted over all these rows. So 1, 2, 10, 13 became 1, 2, 10, 13 was already sorted. 19, 34, 12, 14 became 12, 14, 19, 34, right? Similarly, 45, 32, 109 became 9, 32, 45, 100. Yeah. Now I can specify the axis. If I want to sort along the sort the columns, so I can say axis equal to 0. So it will operate each column, right, along the rows. So its axis equal to 0. So then you see 11945 was already sorted, so that was fine. 23432 became 23234, right? And then 10 1200 was already sorted. 1314 became 91314. So if I want to again sort along the rows, right, so I can, as across the columns, I can just specify the axis to be 1. So if I do not specify the axis, it will sort over the last axis. Clear? Questions? All good? Okay. Similarly, you can find, you can do other things. You can let's say find the mean of the array, right? I want to find the mean of the array. You say the function to use is known as np.mean. XX and this is XX. Okay. Now, when I do not specify along what axis I need to compute the mean value, it will just compute the mean value over all the values of the array. Yeah, and then if I want to, let's say, compute the mean value for x is 0, so it just computed the average value of all these guys, this one, this one, this one, and this one. Yeah, if I want to let's say find the mean value across the rows, like mean value of every row, so we can do that as well. We can just say x is equal to what in this case, 1. So if I do that, so it just found the mean value across all the columns. Is this clear? Yeah, any other questions? Yes. Sorry. NumPy is a library that is created to deal specifically with arrays. Right. It may not have all the mathematical functions, but it's something that is created to deal specifically with arrays. Okay. All right. Now, other things, other cool things that we can do with NumPy. Sorry. Yeah. So there are several functions that we can operate on these arrays. For example, if I want to see what is the shape of this NumPy array, I can just call the method xx.shape, right? So it will just tell me what is the shape of this array. So this xx just has 3 values, right? So it's just for that reason this is 3 comma. Let's say if I want to find the shape of array A, I can just do array A dot shape. So this array A contains 3 rows and 4 columns. So I can find, what column and rows, how many number of columns and rows do I have. If I want to access the elements of the array, right, I can also do that. For example, I want to access all the rows, but I want the first column. So I can specify what rows that I want to access over here and what columns do I want to access over here, right? So if I do that, you see I got the first column, which was 1, 19 and 45, 1, 19 and 45, right? If I want to access the first 2 rows, right, and all the columns, so I can just have array A and I can say 0 colon 2, right, and I just want the first column, so I can just do this. There is a problem here. What is the problem? This is the array. So okay, so I got the first 2. Let's just get all of them, right? So I got the first 2 rows, right, and I want the first column of the first 2 rows. The first column of the first 2 rows is only this guy. The first column of the first 2 rows is only 1 and 19. For that reason, I got just 1 and 19, right? I want the first, I just want these 4 entries, the first 2 rows and the first 2 columns. So I can do 0 colon 2 and 0 colon 2 over here. So I got 1, 2, 19 and 34. Yeah. So similarly, you can slice different portions of NumPy arrays, and you can also use like integer indexing for NumPy arrays. Right. You can also use logical indexing for NumPy arrays as well. For instance, I want to, let's say, get only the first 2 rows, so I can write true, true, and then false. So it will just get me the first 2 rows, right, and then all the columns. Okay, so that we discussed. What else? Then I can also create arrays out of, without using lists, for instance, right? I just want to create, let's say, an array of zeros. So I can do that. So let's say if I have array of zeros. So the function to use in Python is np dot 0 zeros, right? And then we have, then we let's say give the size. So if I just see array dot 0 dot shape, so it gave me essentially a row vector of zeros containing just 10 entries. Now if I want of size 10 by 100, and if I run this, so I can specify the size 10 by 100 over here. So it's going to give me an array of zeros of 10 rows and 100 columns. And if I just want to print it, I can just say this guy, print it. You see, you have 10 rows of zeros but 100 columns. In addition to zeros, if you want to initialize a numpy array of ones, so you can also do that, and the function to use is np dot ones. So for example, is a array of ones, right? So and then let's say I want to initialize an array of 3 rows and 5 columns. So see here I have 3 rows and 5 columns all made of ones. Yes. Sorry. If you do not, then that leads to, or that is linked with the default arguments. If I do not specify what data type to use, it will automatically decide it to be floats. Now let's say I want the data type of integer. I can specify that with the argument d type. So I say d type int. If I run this now you see all of them are integers. So I can specify what data type I want as well. Does that make sense? Yeah. And why is it useful to initialize, to be able to initialize arrays? Because when you will be actually coding, right, and the data that you deal with comes in hundreds of thousands of dimensions, right? Or let's say you have an array of size 100,000 times 100,000. So you cannot manually put in 100,000 squared values and initialize a numpy array. So you can use these functions. Good. Clear? Questions? Yes.
What number can the arrays of go up?
That's a good point. It would be limited by the memory that is available, right? Like for example here, the memory that is available is RAM is 1.21 gigabytes. Oh, sorry, it's 12.68 gigabytes, right? So until I can fill this memory, I can do that. Yeah, that's, if you have a very big array, your program will become extremely slow. Yeah. So what you can do to circumvent that, let's say you want to deal with 100,000 images. I do not have memory to load 100,000 images. So what you can do, you can load them in batches. Let's say you load a batch of 10 images, do whatever you want to do with those 10 images, then you load the batch of next 10 images, you do whatever you want to do with those 10 images, and so on and so forth. Yes. What if you have images of? Okay, so let's say you have 100 files in your hard disk, right? And you want to, access them, right? So what you can, there are functions in Python with which you can perform, like you can list the number of files that are in a directory. You can, for example, find how many directories are there in a directory, how many subdirectories are there, and what are inside those subdirectories, right? And then that is how you can come up with a list of the names of the files, right? So when I say you load them in batches, you just look at those names. Let's say you have 100 names. So it's easy to load 100 names. 100 names can sit in the memory, right? Or even 100,000 names can sit in the memory because they are just strings, right? So you can just load those 100,000 names and then just access 10 file names at a time.
No, I want to know was like, because you say you would load in 10 files instead of storing the values in
Mm-hmm.
an array.
Mm-hmm.
For example, like let's say you're loading images, instead of storing the pixel like the pixel values of the array, or you use like for loop. Let's say you for loop it, and it would load in like 10 of them, and then into a new array, or like into an array. Then after that for loop's finished, you create a new array, for example. Like you would just have an iterator to do all of that for you instead of you just loading. Unless I'm just completely misunderstanding, but from what I got is you're trying to load in all of the photos data into an array.
Okay, okay. So from where I'm coming is a bit linked to machine learning. So let's say you want to train a machine learning model with a batch of 10 images. So you load those 10 images together in the memory and you update the parameters, or like you calculate the parameter updates for each one of those images separately. Then you average the parameter updates and then you update the parameters of the model. And then you move on to the next match and so on and so forth. So, I mean, probably what I was coming at was a bit from machine learning perspective. Any other questions? Yes.
The array of one and to be like array of tens, array of
Good point. So to get array of 10s from array of 1s, you just do this. 10 times this. You got the array of 10s. You want to have an array of minus 1s, right? Many times you would want to have, let's say, array of minus 1s because then you can load the values and see which one of them is still missing, right? So you can find out which one of them is minus 1. So yeah, so for those kind of situations you can do that.
so there's no like np dot 10 or np dot 11.
No, 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 you don't have that.
It's only zeros and ones.
Yes, yes, because you can get the other ones from this. Any other questions? Clear? All right, so I will stop here for you guys. So I'll